In this video, we're going to see how the addition property, subtraction property, reflexive property come up in context in Euclid's elements. Euclid's elements starts with 5 postulates, and the first 3 are about how we're allowed to do constructions, and the 4th one is kind of unusual. It just says that all right angles are equal to one another. And it may seem like a pretty obvious thing and not even necessary to say, but he says it anyway. And this will become a reason that you can use in proofs. So here's a diagram, and the goal is to prove that this obtuse angle, ABD, is congruent to the obtuse angle over here, EGH. And the given information is that ABD and EGH are both right angles. That's why they put this little square there. And it's also given that these acute angles, CBD, is congruent to FGH. So, imagine CBD and FGH reach 30 degrees, then of course the big angle is going to be 120 for each of them. But the way we write this up as a geometric proof is we know about these 2 acute angles, and we know that the other 2 are right angles, but we're going to add these together, but not yet. First, we have to actually say that angle ABD is congruent to angle EGH, even though it's kind of obvious they're both right angles, but it does not say they're congruent. It just says that they're right angles. So we can say they're congruent, and our reason can be all right angles are congruent. That is something we have to say. Now that we have these 2 statements, we can add them together to get our conclusion. We can say angle CBD plus angle ABD is congruent to angle FGH plus angle EGH. I like to say then comma, or another way of saying CBD plus ABD is angle ABD is congruent to angle EGH, which was our goal. And the reason is going to be addition property. Addition property is when we add together 2 congruent statements. And if we don't have this one here, we won't have anything to be able to add to it. Now these properties come up in actual Euclid's elements. Here's a really complicated diagram, but it has here a right angle, FBA, and it has another right angle, DBC. And our goal, at least for here, is to prove that angle FBC, which is this obtuse angle, is congruent, I'm going to make it a different color, is congruent to ABD, which is this other obtuse angle. And the way we do that is noticing this shared piece in the middle, this piece right here. So these things are both right angles, so they're 90 degrees. So this obtuse angle is 90 plus whatever angle ABC is, and this one is 90 plus whatever angle ABC is. And here's the way we're going to write that up. So we were given the 2 right angles. We have to say ABC is congruent to ABC, that angle sort of shared by both of these obtuse angles. That's reflexive. These 2 steps could be reversed also. We have to say all right angles are congruent so that we have these 2 congruent statements so that we can add them together to get the last step, which is ABF plus ABC is congruent to DBC plus ABF, comma, or the obtuse angle is equal to the other obtuse angle. And throughout Euclid's elements, there are opportunities to see these things happening. In this one, we're given this is congruent to that, and this is, and the entire line segment is congruent to the entire line segment. So we will eventually be able to conclude that this piece here is congruent to that piece by subtraction. In this one, we're given that BC is congruent to AD, and BC is also congruent to EF. So we can say that AD must be congruent to EF by the transitive property. And then the goal is to prove that AE is congruent to DF. As you can see, the DE is shared by both. DE is congruent to DE, reflexive. And finally, the addition postulate will eventually get us to that AE is congruent to DF. So these are all things that happen in Euclid's elements. Over here, we're given that this is congruent to that, and also that this is congruent to that. So we're going to be able to use addition to conclude that the entire piece is congruent to the entire piece. And over here, we're given that DEC is congruent to AEB. Those are both 180 degree angles. And whatever this angle is here, suppose that this angle I'm making red was 120 degrees, that would make these things both 60. But in general, these vertical angles are going to end up being congruent to each other, and that one we can do with a reflexive and a subtraction. So I wanted to show you how in Euclid's elements we do see these addition, subtraction, reflexive properties.